Geeks for Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks for Geeks.
Hello everyone, this is Mansi Lokakshi. I have secured All India rank 48 in GATE 2023. So today we are here for ultimate revision on TOC subject. So first of all, before starting the revision, I would like to discuss some of what is the course of TOC and what are some important topics related to TOC. So let's start. So am I audible? Please mention in the chat box. Is my voice properly delivered? Okay, so let's start with the subject. So TOC. So the first topic for TOC is regular expressions, regular expressions and finite automata. Finite automata. The second topic is context-free grammar, context-free grammars, and push down automata. Push down automata. So those who are not aware about TOC topics, so please note this. Who all are like aspirants for GATE 2025, so they can note this topic, and who all are like currently will give TOC, okay, and they are not so prepared for this subject. So I will give you some important topics that if you will revise that at the last time, so still there is hope that you can attempt some questions from TOC. Okay, so this is pumping lemma, and the fifth one is Turing machine. Turing machines and undecidable. Okay, so yes, these are the 5 topics of TOC. So this is the syllabus for TOC, where this covers 50% of the syllabus. Okay, and all these are the topics. Okay, they have some weightage for that. So for the weightage purpose, I will go like topic wise. Okay, I will note you topic wise, like what are the topics important. Okay, so please note this down. I will give you some time to note. Okay, and after that we will move to some important topics which are definitely and necessarily should be covered. Okay, So can you all write hi in the chat box if you are like there for the session? Okay, so these are the topics. This is the portion for TOC. Okay, now let's move on to some important topics which definitely need to be covered. Okay, so important topics of TOC. Okay, so the first important topic for TOC is like why they are important, because from the last previous year, so many questions have asked from this topic. Okay, so please note this: context free language. The second one is decidability. Third is finite automata. And the fourth one is identify class. Fifth one is minimal state automata. Sixth one is regular language. Okay, seventh one is push down automata. Okay, and the eighth one is recursive. And recursively. Okay, so these are some important topics of TOC which you should definitely look up to, okay, before the exam. So I'll wait for a few minutes, okay? So up till then, please write in the chat box if you have any doubt regarding this. Okay, so please note these topics. Hello everyone. So now I think the chat is more active. Everyone there? So have you noted the points? Now let's start. Okay, so let's start the practice, our revision session now. Okay. So I'll write the first question, and how we will go, like you will first attempt it by yourself, and then I'll tell you the solution of the question. Okay, so we'll discuss likewise because it will help you to do your revision on the topics. So ready everyone? So question 1. A context free grammar, a context free grammar is ambiguous if, okay, so option A is the grammar contains useless non-terminals, useless non-terminals. Second is it produces more than one parse tree for some sentence. Third is production some production has two non-terminals side by side on the right hand side. Okay, and the last point is none of the above. So what do you think is the correct one from here? Okay, so what do you think is the correct one? So Ayush is saying B is correct. And B is absolutely correct because an ambiguous grammar. So see, a context free grammar is ambiguous if. What is ambiguous grammar? It produces more parse tree. Okay, when it produces more parse tree for a given string, so it is called as ambiguous grammar. And is ambiguous grammar a context free grammar? Can we say that ambiguous grammars are context free grammar? Yes or no? No, ambiguous grammar are not context free. Ayush, we can't say that. Okay, so have you got it? Okay, so now let's recall some of the properties of ambiguous grammar through question. So I'm writing a question: context free language, and regular language are both closed under the operation. Okay, the operations of option A is union, option second is intersection, option 3 is con, okay, and option 4 is complementation. So what do you think is the correct one? So context free and regular language, so both are closed under which operation? So this is a very good question to revise the concept of like which is closed under which operation. Okay, so the answer for this is A and C. Okay, the answer for this is A and C. Okay, now for the sake of revision purpose, let's note the point like a regular language are closed under what operation and context free languages are closed under what operation. Okay, so I'll give you a note for this. Okay, so note the points. Yes, correct, Jesh. It is a union, but one more option is correct. Okay, for this. So regular language is closed under. So please remember the points as it is. Okay, it will really help you in your question, in your exam. Okay, so regular language is closed under. So first is union, second is intersection, third is concatenation. Okay, and the fourth one is complementation. So these are the points for regular language. Now let's see similarly for context free language. So CFL is closed under. So first of all, concatenation. So is it closed? So CFL is closed under intersection or complement? No, it is not. Okay, so it is only closed under concatenation, but not under intersection or complementation. Okay, and it is CFL is also closed under union. So out of this point, can you say that now they both are closed under union and concatenation? Okay, can we say that from this points? Okay, so let's solve other question. Now consider the following types of language. So first L1 is regular. Okay, and this is given in the question. Okay, L1 is regular, L2 is context free, and L3 is recursive. Okay, L4 is recursively enumerable. Okay, so now which of the following are true? Okay, so that we have to identify. So option 1 is L3 complement union of L4 is recursive enumerable. Okay, so I am writing a short form for this. So this is RE, this is our R, this is our CF. Okay, context free, and this is regular for R. The option second is L2 complement union L3 is recursive, which is R. Third is, so this is the clean closure, okay, of on L1. Intersection L2 is context free, and the fourth one is L1 union L2 complement is context free. So which is correct? So this is the best question to revise our concepts. So that's why I've taken this question. So please think about it for a minute. Try to solve this. Okay. Tell me the answer in the chat box. And then after that, I will tell you the solution. So please keep a pen and notebook with you. Okay. Don't just see this lecture idly, because you have to solve. Okay. Side by side with me. So this, if the third point is not visible, so this is L1 clean closure intersection L2. Okay, so I will erase it and I'll write it again. So third is L1 clean closure, L2 is context free, and highly possibility is there that question may come from this part. Okay, because lots and lots of questions have come in the question from this part. Either they will ask you some property, or they will do some combinations with languages like this. Okay, so I thought that this is very important for you to revise. Are you getting the answers? Are you all solving? Okay, so let's discuss the options one by one. So what is our first option? First option is L3 complement union of L4. Okay, so this is L4 and is recursively enumerable, they are saying. So what is L3? L3 is recursive. So do recursive is closed under complement? Can you say that recursive languages are closed under complement? So let's discuss this. So if L3 is recursive, then we can say that L3 complement is also recursive. Why? Because it is closed under complement. Recursive languages are closed under complement. Okay, so L3 is and if L3 is recursive, so L3 can be recursive enumerable language also. Can we say that? Okay, so L3 complement is recursive enumerable language also. And what is L4 given? L4 is already given recursive enumerable. So now union of this recursive enumerable is recursive enumerable only, because recursive enumerable language is also closed under union. Okay, so those who can't recall the property, just note this property, that if language is recursive, then the complement is also recursive, and the complement can also be recursive enumerable. Okay, and union of recursive enumerable is recursive enumerable itself, because union operation is closed. Okay, is closed. So this is the fifth point. So it is also recursive enumerable. We can say that closed under union. Okay, closed under union. Please be more active in the chat. Okay, so that I can understand where you are getting problem. Okay, and or which topic you are not getting, so I can explain you nicely about that, or else I'll understand that you are getting everything and then I'll go with my flow. So this is the first question. Okay, explanation for the first question. Now the second question is L2 complement union L3, and L2 is given as context free. Okay, so let's discuss the second point. So in question it is given as L2 complement union L3. Okay, and in the question L2 is given as context free. So can we say that L2 complement is also context free? Can we say that? So L2 complement may or may not be context free. Okay, because complement is not closed under complement. Okay, because CF, which is context free, is not closed under complement. So it may or may not be complement. Okay. So let's write the solution for this. But can we say that complement context free complement is recursive? Okay, can we say that context free complement is recursive? Yes, we can say that. Okay, so let's note down this point that L2 is context free, so L2 complement may or may not be context free. Okay, because not closed under complement. Okay, because it is not closed under complement, but definitely L2 complement is recursive. L2 complement is recursive. And in the question, what L3 is given? L3 is already given recursive. So can we say that recursive and recursive is recursive because it is closed under union? Okay. So therefore, we can say that L2 complement union L3 is also recursive because closed under union. Okay. Can we all say that? Okay. So now, so is the second option clear? Everyone? Please write in the chat box. Okay. So now let's discuss the third point. So third point is L1 clean closure union, intersection L2. And L1 is given regular. Can you all tell me in the chat box, is L1 clean closure is regular or not? Can we say that? So is it the property? So those who don't know, this is a clean closure, and L1 clean closure is regular because it is closed under clean closure. Okay, it is closed under clean closure. Clean star also we can say. So L1 star is also regular. This is not star, but it says that it is clean closure. Okay, closed under clean, closed under clean star or closure also we can say. Then our L2 is given as context free. Okay, L2 is given as context free. Now regular intersection context free is also context free. Can we say that regular intersection context free is also context free because closed under intersection with regular? Okay, so this and L2 is also context free. The reason is closed under intersection with regular, closed under intersection with regular. Okay, so this is regular, intersection is CF, so it is also CF. This is also one of the property. Okay, so please keep remember if you don't know about this. Got it, everyone? So third point is clear. So is the third point clear? Now let's move on to fourth one. Okay. So fourth one is L1 union L2 complement. Now in the question, L1 is given regular, L2 is context free, and now only in this point only we have discussed that L2 complement is regular or is context free or not. So it may or may not be context free because context free are not closed under complement. Okay, so can we say that? So this part is not confirmed. So can we say that L1 union L2 complement is context free? Okay, when both of these parts are confirmed for a language, then only we can conclude a language for this. Okay, otherwise we can't say anything. Okay, otherwise we can't say anything. So as this L2 complement part is not clear, so that's why L1 union L2 complement may or may not be context free. May or may not be context free. Now from this whole discussion, can you tell me that which is the correct answer for this? Okay. Okay. Now let's go to next question. Let's discuss the next question. Yes, correct, Jayesh. Okay. Now concentrate on the next question. Okay. So consider the context free grammar G below. So we have given a context free grammar. Okay, we have given a context free grammar. So the grammar is like this: A as B, this is X, and this X has the production of AX, XB, and AB. Okay, where S and X are non-terminals. Okay, they are non-terminals, and A and B, A and B are terminals. Okay, the starting non-terminal is S. As you can see that the starting non-terminal is S. Now I will write 4 statements, and out of this you have to tell which one is the correct one. Okay, so here the first one is the language generated by G. Okay, so this is G. Okay, this is the grammar G is given. So language generated by G is A plus B whole star. The second is the language generated by G is A star, A plus B star. Okay, so if it is hidden, the second option, so it is just the language generated. Okay, the is hidden, I guess. So first tell me about this two option. Okay, then I'll write the next two options. So please tell me about this. So can we say that? So from X, what we can generate? A we can generate, B we can generate. Okay, any times A we can generate and any times B we can generate. Can we say that? Please write in the chat box, okay? If these two are correct or not. So here any times of A, any times of B, one time A, one time B. If we will substitute here in S, so what we will get? A, N, B, N. Okay, same times, same number of A's and B's. And here for X, okay, any times of B, any times of A, and A and B also. So can we generate A plus B star here? Okay, so please listen this properly. See, let's take this AX. Okay, now what are the terminals given? A and B are the terminals given. Okay, so if we have to terminate this X, so how we can write this? A plus B. Okay, this is the way we can write. And if we have to terminate this X with B, so how we can write this? How we can write this? A plus B and here B. Okay, here B we can write. So in any of this, okay, so if any of this A and B N, if the X is given, okay, so what we can say that? Can we say that A plus B and B like this? Or we can also say that A plus B. Okay, this is what can we say that? So this is what it is generating for this X, S, and the for X, these all are it is generating. The productions, if you will see properly. Okay, now if you will combine this A with here, so what it will generate? Okay, so the space is not here, I will write. So if you will combine this, if you will combine here, so can it be A and A plus B? Or we can say that, A plus, or we can say that A, okay, not A. So, or what we can say that, so that it is A plus B and like this. Can we write like this? And here BN, here AN. This way can we write? After the simplification. So can you check from these two options? So anywhere we are getting this A plus B star. But can we say that this is correct? Like this can be written as A star. Okay. And this can be written as B star. And the whole thing in the middle. Okay. Is it matching with the option? Is it matching with B option? Okay. So can we say that B is correct? So clear everyone this question? Anyone having any doubt regarding this question? Okay, so let's discuss the next question now. if G is a context, if G is a context-free grammar and W is a string of length L in language G. Okay, so how long is a derivation? How long is a derivation of W in G? Okay, if G is in Chomsky normal form, which is also called as CNF. Okay, Chomsky normal form. So do we have a direct formula for this? Can you please write the formula? Okay. So can you write a direct formula for this? So the answer, the solution for this is, so for CNF, it is 2L minus 1. Okay, 2L minus 1. And for GNF, it is only L. Okay, so in the question they are asking us CNF, but they can also twist the question and can ask you both CNF and GNF also. So please note it down that for CNF 2L minus 1 is required and for GNF L is required. Okay, so this is the answer. Everyone got it? And you can simply remember it as it is. Okay, no need for how this 2L minus 1 came. Clear everyone? The question is clear? Please write in the chat box if you are having any doubt regarding any question. I am there to solve. Should we move ahead with the next question? Okay, so let's write the next question. Now, which of the following definition below generates the same language as L? Okay, now we have to, so the language is given. Okay, so in the options, which will generate the same language, that we have to know. So xn, yn such that n is greater than equals to 1. Okay, so we have to in the options they will give you the means in the options they will give you which will match this language. Okay, that we have to tell. So E as the production xey xy. Okay, the second is xy x star y plus, and the third option is x plus y plus. So please tell me which will match this question's language. Okay, which will match? So such type of questions are solved by elimination technique. Okay, so what we have to do, we have to eliminate the options. First of all, we will see that what are the languages, okay, generated from this, what are the strings generated from this language. So first string generated is xy. Okay, so can we check that where xy is generated in this? Okay, so let's see that. So in the option 1, can we say that xy is generated? So can we say that for now option 1 is correct? Okay, now here also xy is generated. Okay, but here can we say that xy is generated? What is the minimum string can be generated from this? So here xy, okay, so option 1 and option 2 is correct for xy. Option 3 is also correct for xy. Got it? Okay, now which is the correct one? Okay, that we have to know, right? Now I will tell you. Okay, so let's have some observation on the given language. If you will observe that, so here only, if here 2 is there, so 2 will all will be there. Okay, like x is 2, so y will also be 2. If x is 3, y will also be 3. So the number of x is equals to the number of y. So can we just simply write here the number of x and y? Okay, so can we say that here we can generate number of x and number of y as equal? Okay, but in the option second, can we say that we can generate equal number of xy? No. Why? Because here x can be 3 and here x can be 2 also. Okay, so from here we have generated 3x and from here we have generated 2y. So will our language accept this string? No. Okay, and here also we can generate, so here also we can generate as many as x possible and as many as y possible. Okay, we can generate y as 2 and x as 4. So do they have some dependency on each other in the option 3? No dependency. Okay, we can generate as many as x and as many as y. So there is no dependency. But what our question is saying that we should want dependency. The number of x should be equals to number of y. And here option 3 is not giving that. Option 2 is also not giving. Can we say that only option 1 is giving the dependency, the equality between x and y? Can we say that? Okay, so option 1 is correct. Okay, only option correct is option 1. So I hope you got the understanding for the question. Any doubt in this question? Any doubt, everyone? So such type of questions will also come. Okay, in the question paper, it may come. Okay. Okay, so let's move to next question now. If G is a grammar, G is a grammar with productions, So first production is SAS, SAS. Okay. Second production is ASB. Third production is BSA. And fourth production is this and this. So this is epsilon. Okay. So here we have to tell that which one of the following strings is not generated by G. Okay. The option A is ABAB. Option B is AAB. Option C is ABBAA. Option D is ABBBA. So please tell me the answer for this, like what it can generate. So we will discuss the options one by one, but first I will tell you all to solve these questions. Okay. So check one by one properly and tell me in the comment section. Are you getting the answer, everyone? Okay, so let's solve this question. So what we have to take? We have to take the first production, which is S. And what, so we want A, B, A, B. Okay, we want A, B, A, B. So what we will take here? So we will take here, so see, here A is starting, okay, starting from A and ending with B. Starting from A and ending with B. Can we say that? That we want this production for this? Okay, then in middle, what we want? BA we want. Okay, so can we generate BA from here? And after that, for this S, can we just write epsilon? Okay, can we just write epsilon? So can we say that AB can be generated, is generated from this grammar? Okay, so how our tree, parse tree will look like? S, A, S, B, and here this L, S will expand to this B, S, A, and this S will be epsilon. So the strings generated is this. Okay, can we say that? So option A is correct one, but we want not generated by G. Okay, so let's verify the option second. So this is the best way to analyze, okay, without drawing any parse tree or something like that. So again here, if you will see that first A and the last B. So can we generate from here? Okay, after that what we want? A and A we want. A and A we want. Okay, so how we will generate A and A here? So can we generate from here? From this number of A's we can generate, and after that can we give epsilon to the production? Okay, so let me all give you the parse tree. So here S, A, S, B, and here S will be S, A, S. Okay, and again here it will be, okay, S, A, S. Like this also we can say that. Okay, and here the S will be epsilon, here the S will be epsilon, and here the S will be epsilon. Okay, so what are the non-terminals? A, okay, can we say that? So is the string generated? Okay, can we have one other parse tree also for this? Can you tell me how? Like I have done the splitting here in the left hand side. Can we do the splitting in the right hand side as well for this S? We will get the same string. Okay, so there are the two ways. Okay, so I hope option B is also clear. Now let's see option C. So let's see the option C. Now what we want? A and A we want. Okay, A and A we want for this. After that here we want AB, and after that A. Or can we write like this? So let's try to make a tree for this. Okay. So here, what are the productions we will take here? First of all, S, S, A, S. Okay. From here, from this S, can we take this one? Because we want AB. So A, S, B. Can we take this? So for this S, can we take epsilon? So it will be AB. Okay. AB. So do you think, am I going correct? Please verify it for one time. So is this production correct? Why? It is not correct. Why? Okay, I'll tell you. So if I'll write here, if I'll expand this also here, but can we say that here A, B, A, we will be able to generate. But what we want actually A, B, B. 2 times B we want. But if we will take this production, so we will generate only one B. Okay, so now we have to change our production. Okay, so let's take here again this, which is A, like this production S, A, S. Okay, after that what we will take for here? So can we take epsilon here? Okay, so let's solve this question. So the production earlier we took was not working. So that's why we are trying something different. So this is S. Let's try to generate from this. So this is S. This is S. Okay. Now let's take it as A, S, B. Okay. And here we can take it as B, S, A. Okay. And here we can take S, A, S. And now here epsilon, here epsilon, here epsilon. Got it? Now can we get our string? So this is A we are getting, B we are getting, again B we are getting, A we are getting, and A we are getting. So can we say that A, B, C can be easily generated? Okay. Now let's check for the option D. So here B and A we can generate. Okay. B and A we can generate. A and B also we can generate. A and B also we can generate. But can we generate here single B? This is not possible. Okay, this is not possible because here single B is not present. So if it is not present, so we cannot generate single B in the middle. Okay, it's nowhere possible. So that's why option D is correct. Okay, because this string cannot be generated by this grammar. Okay. So this is how you should eliminate the option and check whether it is correct or not. Everyone got it? Okay, so let's discuss next problem. So we have to identify the language generated by the following grammar. Okay, now I will give you grammar and you have to tell me which is the language generated. So the grammar is S, X, Y. X is giving A, X, A. Y is giving A, Y, B, epsilon. Okay, option A. So language generated from this is A, M, B, N. Okay, M is greater than equals to N. N is B is AMBN, C is AMBN, and D is AMBN. Okay. So please tell me which is the correct one. So please tell me which is the correct one. Okay, so let's verify the options one by one. So first tell me, what is the minimum string generated from this grammar? What is the minimum string? So let's write the language. Okay, let's talk about first the minimal string. So for this type of question, the elimination is the best technique. First see which is the minimum string can be generated. So can we say that here if we will put A and here, yes, yes, Jess, option C is correct. Okay. So here, if we will put A and here if we will put epsilon, so the minimum string is A. So let's check by the option elimination technique that can we generate only A from this or not. Okay, so what we have to put, so can we generate A from here, from option A, can we generate single A? No, because here n value we have to take 1. Okay, n value we have to take 1, and here if n value is 1, okay, so m value should be 2. So can we generate a single A from this? No. So that's why option A is incorrect. Okay. After that, so here n can be 0. Can we keep our m as 1? Okay. So can we say that here from here single A is generated? So there is hope that option B can be correct. Similarly, we can say that, okay, for C as well. But can we say that for D? Here single A is not generated. That's why A and D has gone. Okay, these two options are gone now. Now let's verify B and C. So let's try to generate second minimum string. So which is the second one? Can we generate AA, two A's? Okay, so let's verify B and C from this. So let's keep this as 0. Okay, and now we can take as 2. And so we can say that from option B it is generating. Okay, B it is generating. Now let's see here from this or from C also it is generating. So now we want such a statement that a contrary statement for B or C so that we can verify which is the correct answer. So here we can say that A and B, like this we can generate. Here can we say that A plus we can generate. So if we will put this, what will happen? A N B N and A plus. So can we say that A is strictly greater than B? It is even not equal, but it is strictly greater than B. Okay, so here can we say that what they are saying that greater and equal. So will it work here? No. So that's why can we say that option B is incorrect. And here can we say that here the strict relation is there that A always should be greater than M. Okay, so that's why we will say that option C is correct. Everyone got it? Clear everyone? Please write in the chat box. If you have any doubt, you can still write. Okay. Got it everyone? Okay. Now solve this question. Okay. And now I'm expecting that no one will give wrong answer. Okay, because this pattern of question we have discussed earlier also. So S has the production A S A, B S B, A B epsilon. Now which cannot be generated? Not generated by the grammar. Not generated by the grammar. So A is A, and A. 4 times A. B is A, B, A, B. Sorry, B, A, B, A. C is B, A, B, B, A. And D is B, A, B, A, A, B, A, B. Okay. Now tell me which cannot be generated. Think properly. Okay, take pen and paper and try to solve this problem. So which is the correct one? Please write in the chat box. Okay. Are you all solving this question? Okay, so let's discuss this problem now. Yes, logical. So B and D. So you are saying that B and D cannot be generated. So logical, D can be generated, but B cannot. Okay. So see, from this language only, can we say that A and number of A's. So we will have equal number of A's, equal number of B's. Okay. Yes, B is for sure, which is correct. So can we say that this is a palindrome? Okay, where we will have equal number of A's and equal number of B's, like a palindrome string, like how it is. And so which type of palindrome it is? Odd string palindrome or even string palindrome, we can say that. So it is both. Why? Because see, A, S, B. So here if we will put A, and here if we will put B and B, so this is odd length palindrome. Can we generate even length also? Here B, S, B. So here in place of S, if we put epsilon, so this is B. So this is even length palindrome also. So from the observation of the language, we are getting that it can generate all kinds of palindrome string. So is this a even length palindrome string? Okay, that's why option A is not what we want. Now this is B, A, B, A. So is this a palindrome string? If we will write the reverse of it, so we will get the same B, A, B, A, B. So are we getting the same? No. So that's why option B is correct. That this is not generated by the language because it is not a palindrome string. If we will say this, so this is a palindrome string of even length. Okay. And if we will check this also, so this is also a palindrome string. C. And here for this A, we can put here. So this is a odd length palindrome. Odd length palindrome. And these all are the even lengths. Okay, this and this. So can we say that option B is the correct one, which is not a palindrome string? Okay, so let's see the next question. Anyone having any doubt? Okay, if you are having any general doubt also regarding the preparation, you can ask. Okay, so now I'm giving you some production. So now tell me the grammar generates the language. So A is A plus B. Okay, B is A. Option C is A, M, B, N, where M and N are equal. Option D is A star, B star. So please tell me which is the correct one for this. Okay, so can we generate B star from here? Epsilon and any kind of B, so we can generate B star from here. So can we put here B star? Okay, so how it can be A, B star, B. Okay, so this can be any number of A. Okay, any number of A, B star, B. Can we say that? Okay, and this can be A N B plus. Can we say that? And can we name? So as in this question, this is A is given as M, A is given as M. So in place of N, can we write here M? Yes, D because of empty string. No, no, no. So not just because of empty string we will mark B, because here yes you can mark it as correct, but here what the string, what the general string, overall string is saying, you also have to see that. Okay, so this is one of the reason. But here if the string will come as A, so here if, so see from here A cube and B square, not cube. Okay, so 3 times of A and B. So from option D we can generate this, but it cannot be generated from this grammar. Okay, okay, logical. So that's why D is incorrect, because here less number of A's and more number of B's are generated. Yes, but yes, it is correct that the epsilon you can check for, but here the main logic is that A will always be smaller than B. A will always be smaller and equal than B. Okay, so this is also a logic. No, see, C cannot be correct because A can also be smaller. So can you check here? So see, here B star is generated. Okay, and here if we will put, so here AM, okay, here AM, and here B star B. So can we say that B are in large number and also they can be equal? Okay, also they can be equal. How equal? Because see here, from here if A is there, and if in S we can put epsilon. Okay, in A also if we will put epsilon, so AB we can generate. Similarly, we can generate equal number of A's and B's. But what if in place of A, we don't put epsilon and we put B star? So in that case, can we say that number of B's are greater than A? So there are two possibilities, that either A and B can be equal or B can be greater than A. So Zimping, were you there in the first lecture? Like the whenever the class started, you know? So after this session, if you will see the first class, okay, the starting of this session only. So I've discussed this properties of closure properties. Okay. So generally so that you can also refer. Yes, so B is correct. Absolutely. So everyone got it? Why C and D were not correct and option B is correct? Please write in the chat box. Clear with the logic? So you have to think about every possible thing. Okay. So this was for equal and this was for greater number of B's, and this was for equal number of B's. Okay. Anyone having any problem? So should we move to next question now? Please write in the chat box. Okay, so Jayesh is saying that option A. So in option A, Jayesh, see, we can generate more number of A's also. Okay, so here what it is saying that only B, single B can we generate. Okay, from here single B is generated. Okay, from option A, single B is generated. But from this grammar, can we generate single B? Check this. Okay, so let me clear this so that it can be easily, you will get it. So you have to check for like counter example. Here, if from here only single B we can generate. So from here, can we generate single B? Let's take this A, S, B, A, B. This is the first production only we can take. Okay, and here if we will put epsilon also, still A and B is generated. Here nowhere we can generate single B. So that's why option A is incorrect. Okay, got it, Jayesh? So we have to see this carefully, the options, and how you will get the intuition for this. So how to eliminate this all by solving various problems. Okay. When I was in my preparation phase also, so I also used to face that how the educators can easily eliminate the options. Okay, where I can't even think about it. So it is the thing that when we will solve more and more number of problems, we will also develop that kind of intuitions. Okay, like how to eliminate and everything. So only the magic we can do here is to solve more number of problems. Okay, if we will solve more number of problems, then only we can say that, then only we can easily identify the options. Okay, so those who are present here, those who are really liking the session, please like the session and comment in the chat box. Okay, whatever you feel about the session, was it was really helpful for you or not. Okay, so please comment and like as well. Okay, now let's move on to next question. Now I will give you one finite automata, state automata questions. Let's solve now. You have to identify which language is accepted by that. Okay, so here is start. This is Q0 on B. This is A. So this is Q1 on B. Okay. This is, so these are the final states. So so Q1 and Q2 are the final state. So here it is A. Here it is B. Here the loop of B is there. Here and here. Here Q3 is there. Here A and here B. Okay. Now I am giving you the option. So A, B star, A, B star, A, B star, A, B star. Okay. Second is A plus B, A plus B star. Third option is B star A plus B star. And fourth option is B star, B star, B star. Okay, so verify this and tell me the answer in the chat box. I'm giving you some time to solve, okay, so that you will also think about the question. V Rajput, what are you saying? I didn't get your comment. So Ratandeep is saying that, okay, so if you will learn it from me, so basically I will make sure that, okay, so I will make sure that this subject will get easy for you, the concepts and everything. So sometimes it's not just that we are not able to understand, but from whom we are learning, that also matters a lot. So if the session was really helpful for you, okay, so please like and comment for the session and please try to solve this problem. And if you are having any general doubt about the preparation or regarding something like that, you can also ask that. Okay. So let's solve this question. So first of all, we will eliminate the states where we cannot reach. Okay. So we can say that they are the useless states. So see, with the start, we can reach Q0, we can reach Q1, we can reach Q2. But can we reach Q3? No, we cannot reach Q3. Okay. So let's remove Q3 so that now we can easily identify our language. Okay, so so now we eliminated. Okay, now we will think about the minimum string is accepted here. So A is accepted here. So let's see in the option where a single A we will have. Okay, so here 3 A's are generated, and what we want, a single A. So option 1 is wrong. Okay, so from 2 we can generate single A. Okay, and from 3 can we generate single A? Yes, from 3 also we can generate single A. But from 4 can we generate single A? No, compulsory 2A will generate if also we will put this epsilon and epsilon. So that's why option 1 and option 4 are gone. Now it's time to see for option 2 and option 3. Okay, so let's try to eliminate this. So which is the next string possible we can generate? So here, what is the loop? So can we write the loop like A, B star A? Can we write the loop like this on here? So what it will be? B star A, and can it be A, B star, so this is A, B star, B. Can you all write the expression? Okay, or else we can also go with the options like the elimination technique. Okay, so here so what here we can generate so that this or this can be can get eliminated. Can you all tell this? Okay, so here A plus B star. So here they are saying that this is the superset. But this language is actually not superset, because if you will do with the formula, so you will get that option 3 is correct. Okay, because here B star we will generate, here it will go A, and here after that, here if we will take out for this loop, so it will be A, B star, A plus B star. Okay, so here we can say that, okay, so here generally two loops are there, A, B star, okay, A, B star, B star. Everyone getting this? You can also check it by elimination technique. Okay, so here why we have eliminated option 2, can we generate, so here this option can generate epsilon. Okay, option B can generate epsilon, but in the given language can we generate epsilon? Okay, so that's why option 2 is also gone. So earlier option 1 was gone, option 4 was gone. So which is the correct one? Option B is the correct one. Okay, so if you are not getting how to form this expression, still you can do it by elimination technique. So here in option 2, it can generate epsilon, but here in the original language, we cannot generate epsilon. Okay, so that's why option B is also gone. So the left one is 3. So that's why 3 is the correct answer. Okay, that's how you should attempt the questions. Now solve this question. Okay, so this is 1. Here is the starting. Here it is 0. Here it is 0. Here is the final state. This is 0. This is 1. And this is 1. So this is the language given to us. Okay, where the strings are 0 and 1. So option A is begin either with 0 or 1. Option B is end with 0. Option C is end with 00. Option D is content the substring 00. Okay, so tell me the options now. Tell me the answer, everyone, in the chat box. So which is the correct one? Okay, so here if it was substring, okay, so please remember, if wherever we will see that the substring, so here always it will be 0 and here 1. In the final state it will be always 0 and 1, okay, in the loop if it was a substring. But here we can say that here 1 is not there in the loop, okay, so that's why it is definitely not a substring. So that's why option D is incorrect. Option B, we will see that ending with 0. So here loop of 0 is there. It can end with 0, 1, 2, with anyone. Okay. So can we say that option B is incorrect? So it is begin either with 0 or 1. Okay. So is the option A correct? So if it is begin with 0, so 0 is also a string. So is 0 accepted here? No. If it is beginning with 1, so 1 should get accepted. But 1 is accepted here? No. So that's why option A is also false. Now, if we will check for option C, so can we say that 2 ending with 2 zeros? Can we say this? Okay, so that's why option C is correct. Anyone having any doubt in this question? Yes. Yes, logical. You are correct. Option C is the correct answer for this. Anyone having any doubt in this question? Okay. So now let's move on to next question. So this is the finite automata given. Okay. So this is Q0, 0, 1. Here this is 1. This is Q1. Here this is 0, 1. Q2, 1. And here this is 0, 1. Here it will be Q3. Okay. And the question is, what is the set what is the set of reachable states? So this is reachable states for the input string 0011. Okay, the option A is given as Q0, Q1, Q2. Option B is Q0, Q1. Option C is Q0, Q1, Q2, Q3. And option D is Q3. So please solve the question and tell me in the chat box. Okay, this is one of the easiest question I have given you. So these are some easy questions also are asked in TOC. So I will not recommend you to leave the TOC. Okay, in the starting of this session only I have noted you some important topics. That also if you will revise, still there are hopes that you can attempt questions from TOC. Okay. So this question is, so 0, 0, 1, 1. So here number of zeros and number of ones. Okay. So will it be a Q0 state? So can we just write the output? So it will be form in Q0 state. Okay. Every option has, so option D is incorrect because it is also generating in Q0 state. Okay. Now let's see. So here 0, 0, 1 and 1. So it is also generating in Q2 state. So we can write it as Q2 also. But here Q2 is present. So option B is incorrect because Q2 is not present there. Okay. And here two zeros, one time one, and here one time one. We can reach to Q1 state. Okay. So Q1 is also possible. Here also Q1. But let's see if Q3 is possible or not. So what do you think? Q3 is possible? So here if we will generate 0, then here if we will go with 1, 1, okay, still it is not possible to reach Q3 because for sure we have to generate two zeros from Q0. And then if we will go with 1 times 1 and here 1, we can only reach to Q2, but we cannot reach to Q3. So we can say that with this input string, Q3 is not reachable. So option C is also gone. Option A is the correct answer. Okay, so here we have to check that which is the reachable string. Yes, correct. Logical. So let's solve some other question. Okay, so solve this question now. So here M1 is given as, okay, so this is 0, this is 1, this is the state, this is 0, this is 0, 1. So this is our M1. Okay, now we have M2, 0, 1, this is 1, this is 1, and this is 0, 1. This is M2. Okay, now option A is L1 is equals to L2. Second is L1 subset of L2. Third is L1 intersection L2 complement is phi. Fourth is L1 union L2 is not equals to L1. So what do you think is the correct answer? Okay, please write in the chat box. First, identify the language of M1 and M2 so that you will get what is the correct one. Okay. Okay, so I'm solving this question. Please see carefully like how I am approaching. Okay, so here the loop is there 1 0 1 0. So can we write a loop like this? Can we write a loop like this 1 0? Okay, and this will go to 1. So we can write a loop like this also. Okay, now what is the language I'm getting here? So here 0 plus 1 0. Okay, star 1 1. And what, so this is 1 1, so this is 1 0 plus 0 star. This is how you should write. Here we are going 1 1, and now what we are getting 0 plus 1 star. Okay, this is the language we are getting. After that, what is this language? So this language is 0 plus 1 star 1 1, and this is 0 plus 1 star. Can we say that? Okay, so can you see that they both are equal? Somewhat they both are equal. Okay, can we say this? So that's why option 1 is correct. And if you will take, so option C is incorrect because they both are equal. So that's why option 2 is incorrect. Option 4 is also incorrect because L1 union will not be L1 only. Okay, because they both are equal. And here L1, and if you will do the complement of L2, so it will not be equals to 5, which is also correct. So here, if you are doing complement of L2, which also means that it is complement of L1, so it will not be equals to 5. So that's why can we say that option 3 is also correct. Are you getting this? Anyone having any doubt in this question? Okay. So let's move on to next question now. So I'm giving a language A, M, B, N, C, M plus N. Okay. And here M, N greater than 1 is. So option A is option A is regular language. Option B is context free but not regular. Option C is context sensitive but not context free. Option D is type 0 but not context sensitive. So which is the correct one? Please tell me in the chat box. Okay, please write in the chat box which is the correct one. Option D. Logical, your answer is wrong. Option D is not the correct one. Please try it again. Go for like the closest one. Okay. So first of all, here option A is not regular because here the comparison is needed. Okay. This both and this both should be equal. So regular there is no comparison. Okay. So that's why option A is gone. Option B, we can say that context free because by implementing PDA, okay, push down automata, can we just push all the A's and all the B's and then we can pop all the C's? That's how we can check. Okay, I'll clear the doubt. Okay, option B and D, C and D, sorry. So with the push down automata, can we just generate, if we will push number of A's and number of B's, and in the C if we will pop all the A's and B's, so can we check that they both are equal or not? Okay, so it can be generated with context free. We can count A and B, it should be equal to C. Okay, so that's why we can say that option B is correct because it is context free. Now why C is incorrect? Because it is saying not context free, but it is context free, right? It is not regular because counting is taking place, but it is context free. So here it is saying that it is not context free. That's why we will cross it. Okay, option C is gone. And if it is context free, can we say that it is context sensitive also? But here it is saying that it is not context sensitive. So that's why option D is also gone. Okay, logical, is your doubt clear? Still you are having doubt logical? You can write in the chat box if it is clear or not. So here, if this is context free, so it is also context sensitive. Okay, but in the option D it is saying that it is not context sensitive, so that's why we have marked option D as incorrect. It is context free, but here in the option C saying that it is not context free, so that's why option C also gone. The comparison is needed. Okay, so that's why it is not regular, so that's why option A is also gone. So which is the correct one? Option B is the correct one because it is context free but not regular. So yes. Now, logical, you will answer me that context sensitive. Let's cancel the not here, but context free. So, can we mark in this state? Can we mark option C as correct? Please listen my question. Context sensitive, but context free also. If this is the option C, so can we say that option C is correct? Okay, if the option is like that, context sensitive but also context free, then we can then we can only mark option C as correct. But here not is given in the original question, not is given, so that's why option C is incorrect. Okay, so I hope you got this question. No, I have just changed the question and then I was asking that whether the C option is correct or not. Okay, first time, first see, in original question C is incorrect, but I changed the question. Okay, so the changes I did in the question at that time, it was correct. Okay, now let's solve the next question. Okay, now tell me this. So this will be the last question of our class. So solve this properly. Okay. So language 1 equals to AP, and here P is prime number. Okay. Language 2 here is AN, BM, C, 2M, and here N is greater than equals to 0, M is greater than equals to 0. Language 3 is AN, BN, C, C is 2N, where N is greater than 0. Language 4 is AN, BN, and N is greater than 1. Okay, so L1 is context free but not regular. Okay, L2 is not context free. L3 is not context free but recursive, and L4 is deterministic context free. Okay, so tell me which is the correct one. So here L1 is CSL, context sensitive language. Okay, L2 is context free language. Why? Because the comparisons here we can do, like pushing all A's, pushing all B's. Okay, so this is L2 is context free, and L3 can we say that it is not context free? Because here if we will do the comparison, then this will get left. So how we will do the comparison here? Okay, so that's why this is not context free, and this is equal number of A's and B. So we can say that this is deterministic context free language. Okay, so is the question clear? So here if we will leave, A, okay, and here if we will push two B's and will pop one C, okay, so there we can check that if M is, okay, M is greater than this, B is greater than, is if B is 2 times greater than C, the comparison is only here, which we can easily do. We can just push all number of A's, and when B comes we can use this method, like pushing two B's and popping one C. Okay, and here I have already told you the explanation. L4 is also a direct question, and L1 is also. Yes, correct, logical. Push two B's and pop one C. for every B. Yes, L3 is not CFL. Why? Because here number of A's and number of B's we will check. But for C, it will not left. Yes, correct logical. You are absolutely correct. Okay, so let's keep one more question. The language, the language 0, N, 1, N, 2, N. Okay, 1 is smaller than equals to 10 to the power 6 is. So option A is regular. Option B is context free but not regular. Option C is context free but its complement but its complement is not context free. And option D is not context free. So which is the correct one? Please try to solve this question. Okay, so which is the correct one? Okay, so let me explain this. This is a very easy question. Can you see the range? So the range of n is given as finite. So if you will see this, so you will see this, the comparison is 3. So how it can be regular? But if you have missed this point, so there are high chances that you will attempt this question wrong. So as the range of n is finite, so whenever the finite is there, it is always regular. Okay, it is always regular. And option B is incorrect because if it is regular, it is context free, it is context sensitive, it is recursive and recursive enumerable. So everyone will go yes because it is bounded, that's why it is regular. Correct logical. So here option B is incorrect because it is saying that not regular but it is regular. So option B gone. Now listen carefully for option C. So context free but its complement is not context free. So first of all, this is regular. Okay, this is regular. And regular's complement is regular. And regular can be context free. Okay, it will be context free. So that's why option C is also incorrect because it is saying that its complement is not context free. Now tell me one thing, that if we will, so this is regular complement is also regular. Okay, and it will be context free. But here what it is saying, it is not context free. So that's why option C is also gone. Now, if the language is regular, the language is also context free. But here in the option D, they are saying it is not context free. So that's why D is also gone. So which is the correct one? Option A is the correct one. Okay. Everyone got it? Anyone having any confusion? Okay. Now let's take one more question and then we will end the session. Okay, let's discuss one more question. So, the smallest finite automata which accepts the language here x length of x is divisible by 3 has, so option A is 2 states, option B is 3 states, option C is 4 states, option D is 5 states. So tell me, so x is divisible by 3 they are saying. Okay, so how many states we will have? So the answer for this is, if x is divisible by 3, so remainder will be 0, 1, 2. Okay, reminders will be 0, 1, 2. And this will be the final state. So this can be the Q0, Q1, Q2. And we can draw a diagram for this. So this will be, if they are saying, so they are not saying on which string it is equal. Okay, so we can say it as 0 or 1. Okay, so this is 0, here this is 1. Okay, here this is 1, this side it is 0, this side it is 0, and here it is 1. Okay, so yes, logical, you are absolutely correct. Option B is the correct answer. Okay, so that's all for today's session. I hope you really enjoyed the session. We have solved some quality questions. Okay, you can still revise this session. If you really like the session, you can like and comment as well. Okay, and now if you have any general doubt, you can ask me regarding your preparation. Okay, so I think no one is having any doubt. So all the best for your exams. Okay, thank you so much.